So, you're very welcome to this Saturday session with Exam Revision on Leaving Cert Chemistry. We will begin this live session in just a moment. So, in this video, we're going to explore the effect that temperature has on the rate of a chemical reaction. And we will complete question 3 from the 2020 Leaving Cert Higher Level Chemistry paper. So in this video we're going to briefly explore the effect of temperature on the rate of reaction using sodium thiosulfate and hydrochloric acid. So this diagram is a very clear way to show you how the results of our experiment will differ. Now, from our studies of rates of reaction at Leaving Cert, we should know that the rate of a chemical reaction increases as the temperature rises. So if we look here, we can see at 40 degrees, 50 degrees and 60 degrees, we form a cloudy suspension. And the cloudy suspension gets darker as the temperature increases. So a good place to start would be to look at the key points of this experiment. So to begin, you would get 10 centimeters cubed of hydrochloric acid, and you would add this to 100 centimeters cubed of sodium thiosulfate at a specific temperature. Then what you would do is you would place it on top of a red cross, and you would time how long it takes for the red cross to disappear using a stopwatch. You would repeat this process for the temperatures of 20 degrees, 30 degrees, 40 degrees, 50 degrees and 60 degrees. And you would record a results table that would have temperature, time and rate present. And from that, you would draw one of two graphs. You would either draw time taken versus temperature or rate versus temperature. And as we're going to see in a moment, it's very important that we read the question carefully so we know which graph we're being asked to draw. So if we touch on this diagram here again, we can see that at 40 degrees, 50 degrees and 60 degrees, we can see that the suspension that is formed, which is of sulfur, when we react our sodium thiosulfate and our dilute hydrochloric acid, the suspension becomes much cloudier, much quicker, the higher the temperature. So the X will disappear quicker at 60 degrees than at 40 degrees. Then below this here, I've put a sample of what a results table would look like for this experiment. So you can see that we have our temperatures all listed. The time in seconds will be gotten from our stopwatch, and you could calculate the rate by doing 1 over the time for each of our temperatures. So some top tips for completing this question or experiment in relation to temperature affecting rate of reaction. It's important to check that you have salt on your graph. So salt, S-A-L-T. S stands for scale, A stands for axis, L stands for labels, including units, and T stands for title. So in order to get full marks for a graph, you need to make sure that you have salt on it. Check when you're plotting your graph that you're plotting the correct information. So make sure that you're checking if you're plotting temperature versus time or rate, because that can vary. And you should always be able to explain the trend in your graph. So for example, the rate of reaction increases as the temperature increases, or the rate of reaction decreases as the temperature decreases. So it's important to be able to explain that trend as well. So let's take a look at the 2020 question 3. So this experiment, or this question, is looking at the effect of temperature on the rate of reaction between sodium thiosulfate and hydrochloric acid. In each run, a stopwatch was started as 10 centimeters cubed of 3 molar hydrochloric acid was added to a reaction flask containing 100 centimeters cubed of 0.05 molar sodium thiosulfate. The temperature of the reaction mixture was recorded immediately after the addition of the HCl. In each run, the time taken for the reaction to reach the same observable stage was measured, and the reciprocal of this time may be taken as a measure of the rate of the reaction, so 1 over T. The table contains data collected by the student who used a set of identical conical flasks for runs 1 to 7. So we can see here that they have a table, and on the table they give you the run number, they give you the temperature in degrees Celsius for each run, and they give you the time, how long it took for each run to occur. So if we take a look at the data that we have, we can see as the temperature is going up, the amount of time that it is taking for our solution to come to the same observable level is decreasing. Now, the observable level would be how long it takes for an X to be obscured on a sheet of paper, as I have shown previously in this video. So let's read the questions and see what they're asking. So with the aid of a labelled diagram, so we're going to need a labelled diagram, you need to describe a method for adjusting and measuring the temperature of the reaction mixtures for runs above room temperature. So here you're looking at a description, meaning words, and a diagram. So for part A, you're going to need word description and a diagram for how you would change the temperature of the reaction mixture. Now, this is worth 9 marks, so you're going to need at least 3 points of information and the diagram. Part B then. Part B asks us what is observed. So what is just a statement. What was observed in the reaction flasks during each run. And then part 2 asks us to describe how this observation was used to obtain the reaction times. So those two questions are going hand in hand, but you need to make sure to answer them separately so that you get your full marks and make sure they're labelled correctly. Part C then asks you to copy the last column of the table into your answer bucket and to fill in the missing rates correct to 3 decimal places. So it's very important that you copy the column into your answer book, because that's what it says, copy the column, and then you are going to simply fill in your figures for rate by using your calculator. And we'll go through that in a second. Part D is going to ask you to plot a graph of rate versus temperature. So that's very important there. Like I mentioned in the previous video, you need to check if it's rate or time. So in this question, it's rate versus temperature. And of course, as well, you're going to make sure when you're drawing your graph that your graph has salt on it. Then what you're going to do is it says use your graph to find an approximate value for X in the following statement. The rate of this reaction doubles for every X degrees rise in temperature. So you'll use your graph and you'll have a look and you'll see where we can spot at what interval the rate of reaction is doubling. And then you will be asked to explain your result. So there's a lot of work there. You have to plot the graph, you have to use the graph to figure out something, and then you have to explain how you used the graph to figure that out. Part E then is the last part, and it says the student carried out another run at 40 degrees, but in a conical flask of a different shape to those used previously. As before, 10 centimetres cubed of the hydrochloric acid were added to 100 centimetres cubed of the sodium thiosulfate. The reciprocal of T basically saying their reciprocal is R, which is equal to 1 over T, so that's your rate, is 0.05. Show by plotting it whether the corresponding data point lies on the curve you have plotted. So what you're going to do is you're going to plot the point 40, 0.015 on the graph that you drew in part D. And then what you're going to be asked to do for part 2 was the depth of the liquid in the flask used in run 8 greater or less than the original flasks, and explain your answer. Justify means to explain your answer. So that's worth 5 marks. So I would probably say that if they were to split that up, that would be a 2 for plotting and a 3 for an explanation. Okay, so that's the question broken down for you. Let's go through each part individually now and try and give you the H1 standard answer. So we're going to start by looking at parts A and B. So part A asks you to explain the method for adjusting and measuring the temperature of the reaction mixture with the aid of a labelled diagram. So this question is worth 9 marks, so I would be suggesting 3 points of information, and there also needs to be a diagram as well. So as we can see, here is a diagram, and this is a labelled diagram, and it's showing how we can adjust and measure the temperature of the reaction mixture for the runs in the experiment. So what we can see is that the flask is being heated using a hot plate, and we have put a specific temperature on the hot plate to show that we heat to specific temperatures, and the temperature is recorded using a thermometer. So there we are addressing both the adjusting section and the measuring section of the temperature. So we're showing that it can be adjusted using the hot plate and that it can be measured using the thermometer. And I've included a labelled diagram, so that is me guaranteeing my 9 marks there. Now, part B of this question then, part 1, it says, what was observed in the reaction flask during each run? So we know from our studies of this experiment that with each run, over time, a cloudy precipitate will appear, and this cloudy precipitate is from the element sulfur forming in our conical flask. So for B part 2 then, it says describe how this observation was used to obtain the reaction times. So what you do is you stand the conical flask on a sheet of paper with a red X marked on it. You add your hydrochloric acid, and then using a stopwatch you time how long it takes for the red X to become completely obscured. So that's your answers to part A and part B. So let's assign the marks. So for part A we know there was 9 marks, so there was 3 marks for your diagram and 3 marks for each of the points of information that were given. For B, it was 9 marks in total. So part 1, the formation of the brown precipitate, is worth 3 marks, and then the description of the observation in part 2 is worth 6 marks, so 2 by 3 pieces of information were required there. So let's move on to parts C and D. So part C asks you to copy the last column of the table into your answer booklet and fill in the missing rates correct to 3 decimal places. Now this is worth 6 marks, and to be honest you should be getting the full 6 marks here. It's very simple calculator work. As we've said, and you can see already, the rate is equal to 1 over the time. So I will do one of the rates for you just to show you. So when t is equal to 200, what you'll put into your calculator is you'll put in 1 over 200, and that will give you 0.005, and we can fill that into our table here, 0.005. And I'm going to fill in the rest of the table now using this method. So I have those figures filled in for you now here in the bottom right hand corner on the table, and that gets you 6 marks. So we're going to use these figures now to continue on to part D, where part D asks you to plot a graph of initial rate or versus temperature. And it's important that you can see here that you're looking at the rate versus the temperature. So in our table down below, we're looking at temperature, and the temperature is going to go on the x-axis, and then we're looking at the rate, which is the answers that you've just calculated in part C. They are going to go on the y-axis. Now, a reminder, when you're doing a graph, you need to make sure that you have salt. So you need to have a scale. As you can see, I have a scale here on the side. So scale meaning it's going up in equal units. So this is going up in units of 0.02, because you've got 0.02, 0.04, 0.06, 0.08, 0.1 and 0.12. And with the temperature, it's also going up in an equal scale. You've got a 20, 40, 60 and 80. You also should have your axes labelled as X and Y axes. And then labels indicates that you need to say what each axis represents. So L for labels. So here we can see we've rate, and I've put in the unit, S-1, and I've put in temperature here along the x-axis, and it's given in degrees Celsius. It's important that you put the name and the units because they're both given to you on the table, and you want to maximise your marks as much as possible. T then is title, so your graph should have a title. So I've just pop a title up there, graph showing temperature versus rate. That's enough for this experiment. And now what we need to go and do is we need to go and plot our points. So my first point is 0.002. So that is down around here, my first point. The second point then is at a temperature of 13 degrees, your rate is 0.0005. So 13 degrees is about halfway through, 0.0005, somewhere along there. Then the next temperature is at 22 degrees, it's at 0.009. So that's approximately halfway between 0.02 and 0. So we can go to about 22 degrees and we can go approximately halfway. So that's around there, another blue mark. The next one is at a temperature of 33 degrees, 0.0018. So 33 degrees, that's up very close to 0.02, so that can go there. Then we have at 40 degrees, we've got a temperature of 0.029. So 40 degrees, you go up and plot at 0.029. And you continue to do this for the rest of the figures in your table. So once you've all of those points plotted, you now join them together. So when you're joining them together, it's important that you don't use a ruler when you're joining your graphs, points on your graph together. You do not use a ruler. You sketch along using your free hand like so. Okay, and that is the graph plotted. So D part 2 now, D part 2, it says use your graph to find an approximate value for x in the following statement. The rate of this reaction doubles at every x degrees Celsius rise in temperature. So to answer this very simply, what I will be doing is I will be picking two rates that are double. So I would pick 0.04 and I would pick 0.08. And what I would do is I would run across until they meet the graph and go down to see what the temperature is. And you do the same with the value that is double that rate, which is 0.08. So we can go across here as so, and we can go down. And basically we can read the values here. So I would say that this is approximately about 43 degrees. And I would say that this is about 54 degrees. So if we take the difference between those two, we can do 54, take away the 43. We can say that x would be approximately 11 degrees Celsius. Now, if you do that for every double value on your graph, you will get the same. So if you were to do that for 0.02 and 0.04 or 0.06 and 0.12, you would get a similar answer to D part 2. So the last part then of part D is D part 3. And this says to explain your results. So basically they're asking you, why does the rate of reaction double when the temperature increases? And that is because more effective collisions happen at higher temperatures. And that simply means that more particles are reaching their activation energy for collisions to occur. Now, if we are to assign marks for these parts of the questions, what we can see is that C is worth 6 marks, so that's very simple. You get 6 or not for filling in the values correctly. Part D is 21 marks. So if we work from the bottom, your explanation for D part 3 is worth 3 marks. You're using your graph to find the approximate value of x is worth 6, so that's 9 marks used. So that means that your graph is worth 12. And the way it actually works is your axis being labelled is worth 3. Your scales is worth 3. Your plotting of your points is worth 3. And then your line or curve is also worth 3. So lots of marks there going for your graph. And just to be aware that you would lose -3 for not using graph paper. So if you don't use graph paper in your exam, you are at risk of losing 3 marks for that question. So let's take a look at part E. It says the student then carried out another run, run 8, at 40 degrees in a different shaped conical flask to those that were previously used. As before, 10 centimetres cubed of your hydrochloric acid was added to 100 centimetres cubed of the sodium thiosulfate, and the reciprocal for T, which is the rate, was 0.015. So for part 1, it asks you to show, by plotting it, whether the corresponding data point lies on the curve you have plotted. So we need to go and we need to find 40, 0.015, and what you'll find is 40 and 0.015 is here. And I will do that in a yellow colour so we can actually see it better in comparison to the other ones. So show whether it lies on the curve or not. So very simply, you just need to plot it. We can very clearly see it's not on the curve. So that is part 1 done. So I'm just going to write down C graph. Then part 2, it says, was the depth of the liquid in the flask used in run 8 greater or less than the original flasks? And you have to justify your answer. So the answer is that the depth of the liquid in the flask was less, and that is because it took longer for the precipitate to obscure the red X. So we can see here that it took longer for the precipitate to obscure the red X, and that means that the depth must be less because there is, let's say, a more of a surface area that needs to be obscured, so it would take slightly longer for that to happen. Now, for to assign marks for part E, it's very simple. You get 2 marks for plotting your point of 40, 0.015, and 3 marks for your explanation. And with that, we have completed a full solution of the 2020 question 3 on rates of reaction. So just before we finish up, I just want to show you what the Leaving Cert Chemistry exam revision website looks like. So as you can see here, I have all the units of the Leaving Cert Chemistry course done out for you, units 1 to 11, and there's also a folder there on exam preparation. So for example, if we click into the oxidation and reduction section of unit 6, we can see that I have 5 videos here on all of your oxidation reduction titrations. Those videos go through the experiment, the method, common exam questions, and any calculations. And there's also a Leaving Cert Chemistry sample solution done out for you for an exam question of that experiment. You can also see that there is a self-correcting quiz, a PowerPoint presentation, and of course the H1 standard notes. There is also an area where you can build your own exam to test yourself on the titration questions or any part of the Leaving Cert Chemistry course, and marking schemes are also provided. So the standard plans on ExamRevision.ie are $19.99 a month, and premium plans are $29.99 a month. And for today, on this Saturday session, if you wish to sign up to a standard or premium plan for Leaving Cert Chemistry with Exam Revision, you can use the discount code LCChem20, and that will get you 20% off. So if you need any guidance for Leaving Cert Chemistry, don't forget you can get in touch with us here at Exam Revision. We're on Twitter, Instagram, TikTok, Facebook and YouTube. And of course, you can visit our online learning platform, ExamRevision.ie, where you will get access to the full Leaving Certificate Chemistry course done out in video format, H1 standard notes, PowerPoint presentations, and of course self-correcting quizzes and access to previous exam papers. So that's it for today's Saturday session. Thanks for joining in, and hopefully we'll see you at the next Saturday session very soon.